Hello everyone, it's Wilson here. Today let's solve this trig equation. We are going to solve this equation on the interval from negative infinity to infinity. So in this case, we are actually going to get infinitely many solutions, and we are hoping that we can come up with a general formula for all the solutions that we have on this interval. Okay, so now what we're going to do is that, just like usual, we are going to isolate the trig function, right? So we don't want some other stuff on the same side as the trig function. So we want to move everything to the other side. That's not part of the trig function. Okay, so first we are going to move the 1 to the right hand side. So that means we are going to subtract 1 from both sides. So then we are going to be getting negative tangent of x minus pi over 3. And that's equal to, if we subtract 1 from both sides, we are going to be getting negative 1 on the right hand side of the equation. Okay, and then what we do is that we need to multiply both sides of the equation by negative 1. Then we are going to be getting tangent of x minus pi over 3. And that's equal to positive 1. Okay, so now this equation tells you that tangent of some angle, okay, tangent of some angle is equal to 1. And so we just need to figure out the reference angle here, and then we also figure out the quadrants that the angle belongs to, and then we can come up with a general formula. Okay, so first we are going to write down the reference angle. The reference angle is going to be what? So as you can see here, whenever tangent is equal to 1, then we have those kind of angles will have a reference angle of pi over 4, because tangent of pi over 4 is going to be 1, right? So reference angle is pi over 4. And then, of course, because it's a 1 here, then we know that tangent is a positive quantity. In this case, tangent of that angle is positive. So that means we need to write down the quadrants, so that by combining the reference angle and the quadrants, then we can come up with the actual angles that we want. So regarding the quadrants, then, as you know, because tangent is positive, remember that in first quadrant, every trig function, right, of those angles in the first quadrant will be positive. So we are going to get quadrant 1, right? And then the other one would be quadrant 3, because tangent is positive in quadrant 3. Okay, so now we have the two quadrants, and we are going to exclude quadrant 2 and quadrant 4 because tangent is negative in those two quadrants. Okay, so now what happens is that in quadrant 1, okay, in quadrant 1, we are going to get the same angle as the reference angle. Right, so whatever that's inside the tangent, okay, so just make a note here. So whatever angle that you put inside the tangent, and that's equal to 1. So that angle, right, the angle, one of them is going to be what? Pi over 4. That corresponds to the quadrant 1. Okay, so that corresponds to quadrant 1. So this one corresponds to quadrant 1. And then what about the other one right here? The other one is going to be what? In quadrant 3. So for the one in quadrant 3, then we are going to be getting 5 pi over 4. And so you know that this one is in quadrant 3. And now we're getting coming up with the general formula, then we should look for patterns, right? So in this case, you can see that if we are graphing the two quadrants, okay, so if we are graphing the two quadrants, just make a tiny sketch right here. So let me just use the line tool to make it look better. So I'm just going to make a tiny sketch right here. This is not really formal work. This is more like a scratch work here. So what really happens is that we have one of them is the pi over 4. So that belongs to the first quadrant. And then it lies on the line y equals x, right? So that one is going to be what? Pi over 4 that you have right here. The other one is going to be what? On the opposite end, right? So that's 5 pi over 4. Okay, so the angle actually goes all this way. So see what's going on here is that the difference between the two angles is that it's pi, right? It's 180 degree because this one is 45 and that one is 225. So how do you go from the first one to this one here? All you need to do is to add pi to it or add 180 to the pi over 4 so that we can get 5 pi over 4, right? So now we can start coming up with the actual solution. So we know that the angle is x minus pi over 3. So that means we are going to have the x minus pi over 3 right here. Okay, so x minus pi over 3. And what is that equal to? That's going to be equal to, as I show you, it's going to be pi over 4, 5 pi over 4, right? Let's list the angles right here, pi over 4, 5 pi over 4 here. And then you may say, what about the next one? The next one, it's really coming back to the first quadrant, but then you need to add 2 pi to it, right? So adding 2 pi to the pi over 4, then that would be what, 9 pi over 4. Yeah, so how do we obtain this one? This one comes from pi over 4 plus 2 pi. Okay, so what about the next one? The next one is going to be, so if you add another 8 in there, so it will be 13 pi over 4. And so if you look at that one, then that's going to be, this one is obtained by using 5 pi over 4, and then you're adding 2 pi to it. Okay, but this actually, this pattern right here that we're writing down, it's just using different angles to obtain. Like for example, this 9 pi over 4 is obtained by using the pi over 4. The 13 pi over 4 is obtained by using the 5 pi over 4. In fact, because the angle, the difference between the two angles, right, is really just 180. So instead of using two angles to obtain the other angles, we can simply just use the most basic angle that we have in quadrant 1, and then we use it to obtain all the other angles. Then you may say, how do we do that, right? How do we do that? We can do this. Just look at the pattern here. The coefficient for the pi is 1. The coefficient for this pi is 5. The coefficient for the pi is 9, right? I'm not talking about the denominator here, so I'm just looking at the numerator. So 1, 5, 9, 13, right? So think about this. To go from 1 to 5, all we need to do is to add 4 to it. To go from 5 to 9, we are going to add 4. To go from 9 to 13, we are going to add 4. So do you see what's going on here? The denominator doesn't change. So in that case, we can come up with a pattern that we are really just adding pi over 4 pi over 4. Yeah, so for example, if you want to go from pi over 4, right, to 5 pi over 4, then you're adding, what do we add? We are going to add 4 pi over 4, as you can see, right? As I pointed out, you're going to go from 1 to 5, you add 4. Go from 5 to 9, you're also going to be adding 4. So same thing here, but remember the denominator doesn't change. So you are actually still keeping the denominator in there. So you're adding another 4 pi over 4. And then also just keep going, right? Then adding another 4 pi over 4. Do you see what's going on here? You're adding pi, adding pi, adding pi, right? So now we can come up with a general formula. We have x minus pi over 3. Yeah, why do we put x minus pi over 3 here? It's really because that's the angle that we have inside the tangent function. Okay, so that's equal to what? That's going to be equal to, starting with the base angle, we have the pi over 4, okay? And we add n pi, where n is an integer, so we should indicate that n is an integer. This means that n is an element of the set of integers, right? So let's make a note here. This is the set of integers. And so because integers can be positive or negative, that means we can also be subtracting pi each time, right? So if n is -1, then we are subtracting pi. If n is -2, then we are subtracting pi, and then subtract one more time. We subtract the pi twice. So we are subtracting 2 pi. Okay, so we can also go in the negative direction. So now we already come up with the general formula, but that's not what the final answer is, because remember we are solving an equation, so we are supposed to be solving for x. We are finding x. So we need to isolate the x in this equation here, and that can be done really easily. We just add pi over 3 to both sides of the equation. So we are going to be getting, what is that here? X, right? And then we have pi over 4 plus n pi, right? And then you are going to be adding, what are we adding here? Add pi over 3 to both sides of the equation. So now if we're adding the pi over 3 and then there is a pi over 4 here, we can combine them together into just a single fraction. Getting the common denominator, we are going to be getting what? It's going to be 12, right, at the bottom. So we are going to multiply by 3 pi plus n pi plus, and then this pi over 3 is actually what? Also change it to 12 and then multiply top and the bottom by 4. So we get 4 pi over 3. So our final answer, okay, would be 7 pi over 12 plus n pi, where n is an integer. I will just write it down one more time again because I'm putting down my final solution right here. So that's my final solution. So how do you generate a few solutions for this equation? It's just that you just plug in some integer values for the n, then you can come up with some solutions. For example, if you plug in 0, then 7 pi over 12 is one solution. If you plug in 1, then you are going to have 7 pi over 12 plus pi, right? If you plug in 1. So that's another solution. If you plug in -1, then it would be 7 pi over 12 minus pi, which is -5 pi over 12, right? That's another solution. So that's how you generate some solution using this general formula. Okay, so that's how you do this problem. How do you feel about this problem? Okay, so if you like this video, please give me a like, subscribe my channel, and share my videos to others. It will give me support to make more videos. If you have questions or have a topic that you want me to talk about, please leave me a comment. Thank you for watching this video. I will see you next time.